somewhere that emanates from the NOC. So if Ofir inspires you such, feel free to try to own it. So anyway, without further ado, here's Ofir. Thank you.
Good morning, everybody. Here are the survivors of last night. I appreciate that. My name is Ofir Arkin. I'm the CTO of InsideX. That slide. And what are we going to talk about today? We'll try to understand what's network access control, what it should do, why there are so many problems with the technology and so many vendors. Also, we will see what solution should have, what are the different components, and how we can bypass each and every of the components, and then we'll show you some examples from live, well, basically examples from some solutions. Please feel free at any moment, just raise your hand, ask a question. Basically, I'm here to answer your questions. So you can read that yourself. Okay. So, as Bruce said, network access control is basically the hottest topic today in network security. It's regarded to be the next big thing in the IT security space. A lot of vendors jump the bandwagon because it's cool and there's money there. The truth is that the first company to speak about the concept that is similar to what we have today is Cisco in 2003. It was the first concept to be introduced as something that they tried to use in order to combat viruses and worms as a lesson from Blaster and Ichi and all of those derivatives. The problem is that we don't define NAC. Well, nobody knows or nobody actually tells nobody whether NAC is a compliance solution, a security solution, or another solution, and what it actually tries to solve. The problem that this solutions try to solve is pretty much clear. If you run a network, or if you're hacking a network, or if you're in charge of a network, basically you know that the internal networks are getting more complex and more dynamic, and usually IT doesn't know what happens there. Who's on the network, what's being done on the network, what the network looks like. Basically, people bringing their stuff from home, plugging into the network. In most organizations, they will be able to get an IP address and basically do whatever they want. That situation basically jeopardizes the stability and integrity of the network and the data, and basically it's something that companies started to be worried about. So it's not only the information theft, it's not only the worms, the viruses, the information leakage, it's basically the lack of general control that we have over the enterprise LAN. So we have a breed of software and hardware solutions that try to have some kind of a solution for control of the elements on the network. And the problem is that we have different methods and different solutions. This is why I decided to name this slide as My NAC is Not Your NAC, because at the end of the day, nobody knows what's network access control. There's no standard, there's no common criteria, and there are various initiatives that tries to basically take more and more companies under their initiative and basically try to combat the world like this. So there's the first and foremost is the Cisco Network Admission Control, then the Microsoft Network Access Protection, and the Trusted Computing Group. If you go to one of these companies' website, you will be able to see the list of companies that participate in these efforts. Some of them may include more stuff, for example, interoperability between things, and some of them are just supportive things. So as you may understand, there is no definition of what NAC is, what components a NAC solution should have, or what a NAC solution should adhere to. So it's kind of an open thing that anybody can jump on. So in my opinion, if we look at NAC, we look at access control first. And only then the secondary task is to ensure compliance. But when we talk about security, then the first and foremost thing that we need to understand is that network access controls means controlling whoever accesses the network. If I want to control whoever accesses the network, it means that I need to understand who's on my network and who's accessing the network in any given moment. And that basically is the root of all evil with most of the network access control solutions, because they don't look at angle, they just look at the compliance angle, and at the end of the day, they just say, well, we will make certain that the element is compliant with a certain policy that you have. Usually it involves Windows, usually it involves the elements they can access or put an agent on, and they stop at that point. But network access control is more of a controlling access to the network and then a compliance solution. And we need to understand that, because if I just have a compliance solution, then it's not really about, it's really about controlling access.
Why do you say that they're not about access control?
They are about access control, but most of the NAC solutions out there don't look at that particular angle. What they're doing, and I'll show that later, what they're doing is that they're going to tell you, okay, install agents on Windows-based machines, and we will check that those Windows-based machines are compliant with a certain policy. But if you plug in a Linux machine, they'll not know about that and don't do anything about it. As the presentation will progress, you'll see more and more examples that basically you'll see that you have an ability to plug in your system, and those solutions will completely ignore your system or would not have the ability to do these type of checks, or basically not know that you're there. Yeah, well, you wait and see. Not a problem, I'm here. So my definition of network access control is that network access control is a set of technologies and defined processes that first needs to allow only authorized and compliant devices into the network. So if we look at the capabilities that a network access control solution may have, is first and foremost the ability to detect new elements that operates on the network as they are introduced in the network, to provide the means to authenticate a user no matter where they're authenticating from. Then we go into endpoint security / compliance assessment, is basically the ability to assess whether an introduced network element has the right operating system, install patches, AV software, install applications, and so forth. Quarantine is basically the ability to isolate a certain element from the rest of the network. Either it is triggered when a new element gets on the network and immediately being quarantined, or when the element is found to be non-compliant, and then it is put on quarantine until the user remedies the issue that basically got the element to be on the quarantine using remediation servers. Remediation is the process of fixing the issue that basically prevented the element from accessing the network. Enforcement is basically restricting the access. Authorization is verifying the access to network resources, which basically integrates with other authorization schemas that might be in place. And the last function is post-admission protection, which is basically continuously monitoring users, elements, and their actions for suspicious activity. Now, basically, there are a lot of functions that may or may not inside a network access control. As far as I believe, there are some things that may or may not be belonging to a network access control solution. In my understanding, authorization is something that should be provided by other security solutions or other technologies inside a network, like Windows domain hierarchy, using single sign-on and so forth. With post-admission protection, I'm still debating with myself if this is something that should be inside a network access control or not, but it's just a matter of definition. So, after understanding what we're up against, what are the methods and what it may include or may not include, then what are the attack vectors that we may have on a network access control solution? The first and foremost is the architecture itself, how the solution is built, how the different pieces interact with each other, what's the inner working of the solution, and in most of the cases you'll be able to find some stuff there as well. Then we look at the technology that is being used with a network access control solution, how it does element detection, how it performs quarantine, what are the enforcement capabilities, what it's capable of doing in endpoint security assessment, etc. And then we look at the components themselves as a security, as a technology. Any component of the solution can be attacked, mostly client-side software, and I'll show you examples of that, and server-side software and hardware that can be attacked as well. Questions until this point? No questions. Okay, cool. So, starting Element detection, basically, element detection is one of the core features that must be supported by any NAC solution. And I've written basically two definitions of element detection. One of them says element detection provides the ability to detect a new element operating on a network, and the other says element detection must detect in real time a new element as it attempts to attach itself to the network. There is a big difference here between definitions. The idea here is that if I would like to ensure that I do the right things with network access control regarding element detection, I must detect the elements as they are introduced to the network in real time. Because in that certain point, I'm able to have a decision like to quarantine the element and prevent the element from accessing the network. But if I'm not able to understand that the element is on the network in real time, then the element has a window of opportunity between the time that it is introduced to the network until the time that the solution will detect its presence, that it is able to attack or do other things on the network. And that's a definitely no-no when we're looking at a security solution that needs to prevent access. There are solutions that basically lack a good element detection capabilities, and in that respect, it will take them some time until they will detect an element that operates on the network. But at the end of the day, if you are not detecting something that is on your network, then you can't really defend against it. So when you're looking at a NAC solution, the questions that you need to ask yourself regarding element detection is to evaluate how the NAC solution basically detects the presence of a new element, if this detection has been performed in real time, and how this information stays current, because we may need to understand more contextual information regarding the elements with the network access control solution. So there are a variety of methods to perform element detection. They are part of network access control, starting with DHCP proxies, authenticated DHCP, DHCP protection, which is provided by switch manufacturers, broadcast listeners, switch integration, 802.1x, agent software, inline devices, out-of-band devices, and proprietary methods. I will be giving examples regarding all of these methods in just slides. Another interesting point, an interesting method a capability that we need to closely examine is quarantine. Basically, with quarantine, there is a variety of methods that allows an element to be isolated from the network. One of the things that we need to remember is that quarantine holds the soft targets off the network. Basically, their level of security is the lowest all of the elements that operates on the network, and they are aggregated usually in a certain subnet or in a certain area. That makes a perfect attack vector as well. But even before that, we need to assess how the quarantine mechanism works and whether or not this quarantine mechanism is bypassable. Another key point which I started to talk about is that quarantined element has the lowest level of security, and the biggest problem here, able to interact with other quarantined elements. This means that the quarantine area is a shared medium which allows one of the other to speak to each other. Now, if I'm an attacker, I would like to get onto the quarantine area if it is a shared medium, because that would make me see all the other soft targets that that particular network has, and would allow me to try to attack them, and there will be the lowest hanging fruits of the network itself. So for me, it would be the easiest way to try to attack the network. Attach my machine, get on the quarantine, try to attack the lowest hanging fruits, to try to inject what they have, hopefully not being able to be detected. And at the end of the day, I did my job because I was able to infect some machines of that network when I got access to the network. So one of the biggest issues here is making sure the quarantine is not a shared medium, and if it is, then you have a big problem, in my opinion.
But if NAC's working, isn't the quarantine guess you wouldn't care about them anyway?
No, because at the end of the day, your phrase that NAC is working, it depends how it works. It's like any other technology that you're saying it's working, but it depends on what it is doing and how it is being achieved. Since there is no standard whatsoever that enforces a certain solution to work according a certain way, you can't really assess what it is doing, and therefore you need to look at any of the methods that it uses in order to provide with its functionality and assess it by solution. So there are some ways to perform quarantine. Some of them are really bad, such as dedicated subnets, dedicated VLANs. These are shared quarantine, shared medium quarantines. Dedicated VLAN is another bad thing, since this is a paired port policy. This also means that you can't hook up more than a single element to that particular port. I would be happy to meet an enterprise that has this actually done, meaning that they have a single element per port. From my experience, that never happens. There's the better way to do quarantine is to have dedicated private VLANs. It means that the element is on its own private VLAN. It can't talk to any of the other devices. Be done on higher end switches like the Cisco 6500s that you can actually do this. This also involves with putting ACLs in place that make that happen. And there are other ways to do this, such as isolation using layer 3, ACLs, and isolation using layer 2. The problem with layer 3 is that still the local subnet is fully accessible to whoever is put on quarantine using that, and also the fact that they can basically attack the devices there and use them as an access proxy to other parts of the network. Of course, this also holds true for dedicated subnets and dedicated VLANs, because they are also shared mediums and they can still suffer from the same stuff. So when you examine a solution, you need to ask yourself a lot of questions regarding quarantine mechanism. The way it operates, is it a shared medium? Can it isolate the device as soon as it is detected to be as soon as it tries to attach itself to the network, because then basically that device will not be able to do anything unless the next solution will allow it to. Does it allow to use specialized hardware? Does it use switch integration to get the information about the new element, and also to put the element on a dedicated VLAN? And can it quarantine virtual machines, which is found more and more in enterprise networks? One of the interesting stuff here is some of these solutions basically rely on the switch capability to provide with dedicated VLANs that isolate devices. The problem here is that in some organizations, depending on the way the switch infrastructure is being built, it won't be useful to do that, because you're susceptible to VLAN hopping and other things that some of the lower access switches will not be able to protect against. So not all the time when a solution provider comes to you and say, well, we do VLAN isolation, it means that your infrastructure can really do that. As I said before, when you look at the solution, you must ensure that the solution has a private quarantine. The quarantined elements can't talk to each other, and of course can't talk to the network. And as I gave an example before, a PVLAN is a good example of that. Jumping off to enforcement, any questions at this point? Okay. Promise examples. So basically with enforcement, we need to ask ourselves how the enforcement is being done, whether this is something that is being done at layer 2 or layer 3, whether and how these actual devices are being enforced. If this is layer 3, it means that usually routers, switch routers, or other dedicated devices will perform the enforcement. It means that the local subnet is still accessible for that particular element, and it means that in most cases we may find ways to bypass it using other elements as our access proxy. Layer 2 methods, in my opinion, are most powerful, although some of them are not that powerful. It also provides you with the ability to isolate these type of devices without touching switches, without using the infrastructure. These type of solutions need to be looked at their solution, because not all of the solutions are good as other solutions. There are also the switch manufacturers, networking gear manufacturers like Cisco, Juniper, Extreme, which basically their strength of doing the enforcement varies from one vendor to another. Here they basically utilize their ability to understand that the element is on the network, since they are the switch manufacturer, and they can basically introduce the best enforcement possible and the best defense possible, because manufacturing and the element needs to connect to it. Of course, there are some problems with that, usually associated with cost and other things that we'll cover later.
Okay, you say that requires it be a single vendor shop, and I just like to take the small issue with that.
Mhm.
The TNT standards that you mentioned earlier, talking about standardization, the whole point of that standards effort is to make NAP possible across multiple vendors using established protocols like DOT or whatever.
Mhm.
So it's not a perfect solution, but it doesn't require.
Usually, technically it's true, but usually you'll find Cisco equipment inside most of the big boys networks, and in that case, Cisco is not part of TNG. That said, it doesn't mean that it can't be used in order to do stuff. But if the appropriate software is not deployed on those switches, then you're not able to participate in whatever thing you would like to do with switches. And that's usually, there are companies which their solution tells you that they will use whatever there is on the network in order to perform network access control. But in those cases, what I found is that the enforcement is being done at layer 3 and not in layer 2, and their element detection is problematic. So in that case, if you have a one-stop shop from one vendor, not that I'm saying that this is what an enterprise should have because it never happens, that tactic if you have that. But the reality is that people don't want to or can't basically have a one-stop shop, and they don't want to invest the money in upgrading the equipment in order to have the ability to do, for example, 802.1x because the cost still is high. Moving forward, basically methods for enforcement are a lot of methods. Authentication methods like 800 which can be combined with enforcement, shutting down switch ports, assigning separate VLANs, assigning subnets using DHCP, the IPS style of I don't like what this element sent and I'm just killing it. Layer 2, which manipulates ARC tables and other stuff, inline devices, etc. There are basically a variety of methods here that we'll go over in the examples. Going quickly through the endpoint compliance assessment, there are some major issues here as well. Basically, the agent-based versus agentless issue, the managed versus unmanaged elements, the Microsoft Windows versus we have other operating systems as well problem. And basically, these other than the quarantine and enforcement and, of course, element detection, is another extremely important thing to consider. When we look at agent-based, of course, agents provide with wealth of information, the best information that you can basically anticipate from an element. It may detect changes that happens on the element if that agent is capable of. But the other problems is that the biggest issue is the catch-22 issue, is where do we need to install the clients? When you go to an organization and you ask the organization, okay, how many Windows XP Service Pack 2 machines do you have? They say, well, we have about this and that number, and usually they are wrong because they have more. The problem is that most organizations do not know this type of information, and not all of the machines that are Windows-based logs onto the domain and are happy participating in the IT effort. So in most organizations, at least from my experience, between 10 to 25% of all Windows machines will be outside the domain. They are going to be non-manageable. It means that not only that they're going to be outside of the domain, or that systems inside the domain basically will have personal firewalls on that will prevent IT from managing these devices if they don't have GPOs. So basically, the problem of where do I need to install this agent is the biggest problem that agent-based software currently faces. Other interesting considerations that usually security guys don't care about is that this is another client among many, and this also has a performance impact over the element that we install the agent on. If you basically work for a software company that has agents and you do pre-sales, you know companies do not like to install agents on their systems, period. That's a big problem, and it's basically showing its ugly faces more and more in these days. Also, some other interesting points. Usually those agents are available for Microsoft Windows operating systems only. It takes time to implement, takes time to enroll. There are security breaches which are associated with client software because there is no client security whatsoever. The funniest ones that I always like to mention is, and I saw it in my own eyes, although it was fixed, the semantic client had the ability of a user to right-click and say disable. So basically, if you had the client installed on your machine and you didn't want to play the NAC game, just right-click it, say disable, and that's it. It was lately fixed, but this was one of the favorite examples that I had. Cisco had issued an interesting advisory recently regarding 802.1x supplicants. I suggest you read it. There is a link in the presentation for it. Very interesting how you can just figure out everything about the NAC infrastructure from that. Also, another interesting point that a lot of people don't consider is how and what type of information that we're looking for. Most of the solutions will go to the registry. They will look for the right key. They'll say, oh, we have the information right. That's good. Well, that's the another bad thing, because I can create those keys manually, and I can just hook up the values, and those systems and most of the solutions will never know that I've entered this manually. So although my system will never have the type of information that really needs to be there, but the registry will say otherwise, then they will blindly say, oh yeah, that's fine, and will allow me on the network. So that's another interesting point. So basically another point before we unmanaged elements pose another big problem for agent-based software. First of all, locating the unmanaged elements, knowing who they are. Second of all, most of the solutions today use some kind of a vulnerability assessment capability in order to assess the security of that element. Who can tell me why this is a really, really bad idea? Oh, come on, that's easy. First and foremost, if I run any type of Windows newer than Service Pack 2 with XP, it means that I have personal firewall enabled by default. If I run any new Linux machine, I have personal firewall by default. If I run Solaris 10, I have personal firewall by default. So all of these devices basically will sit there and will not send anything back to those vulnerability scanners, meaning, hey, I'm fine, right? I don't have any port enabled, I'm good. No, of course not. So in that case, the type of assessment that these devices, if you are able to find them, the type of information that it will give you back, that's another interesting point. If you look at the agentless solution, then of course the advantages here are pretty much straightforward. There's no need to install additional software, fast deployment, and of course introducing custom checks is really, really easy here. The problem here is that agentless software depends on a certain service accessible in order to provide with the information it needs, and there is a possibility to gather less granular information about the device, depends on which methods you're using for agentless probing. And of course, the information that you probe for also can be spoofed. Unless you, the moral of the story here is that unless you know which are your unmanaged devices and how your network looks like, then in both solutions, agent-based and agentless, you will lose, because you need to assess what you can do and what you can't do, and then make the enterprise adhere to the solution, and not just saying, okay, we have only a certain number of elements that we can check, and we are going to be finished with that. That's a losing strategy. Another possibility of doing checks is using dissolving agents. The only problem here is that you need Microsoft Windows operating system, and you need local administrative rights or power user rights, which not be found for everybody in an enterprise. And that brings us back to an interesting key of our discussion, the key point. Basically, what's the risk? And network access control, at the end of the day, is a risk reduction solution, because when it makes sure that you're running whatever your organization wants you to run, the type of applications that are out there, the type of patches that they want you to have, this means that this is a reduction solution. The only problem is that your organization might not be fast as it like with deploying patches, with deploying service packs, with putting these onto the machines. And that's also a catch-22 question here, because then people would say, well, I would like to have a solution that will see whether or not there is an attack on the network, like an IPS, and have that integrated with an NAC solution. Okay, that's fine, but if you wanted to have an IPS, then why not buying an IPS and not buying network access control? Because if you can't ensure that the type of patches are installed on the machines and the type of service specs are installed and the type of security that you would like to ensure on the endpoints is not there, so your network will be problematic as is, and that doesn't really relate to network access control. It will relate to the way that you do management of your network. Okay, so one last theoretical slide. For clients, this is the advisory from Cisco regarding their problem with the 802.1x applicants. It's really, really funny. Also, there's a new trend that I'm seeing happening is that there's a talk at Black at Amsterdam next week about someone who basically reversed engineered the whole Cisco NAC protocols, and basically he's able to inject whatever type of feedback through the questions that he's being asked by the Cisco ACSs. So that's really cool because you can just come with this type of thing, inject back the type of information they expect you to, and basically be on the network without any problem. I have a question there. Yeah, the Cisco Trust Agent. The Cisco Trust Agent. Basically, it's not only the CTA. It's as far as I understand, and I haven't seen the talk yet because I couldn't get a leaked presentation of that. But it's not only the CTA. It's also other stuff. They have like 5 or 6 different clients, and most of them use the same engine. At least 4 of them. So that's going to be interesting. Okay, questions? No questions. Okay. Yeah. The CTA, the CSA, not the one that they bought from Meeting House, and I think the rest of the bunch are also using the same stuff. If you look at their advisory about the 802.1x applicants, you are able to see all the list of all agents because they were all vulnerable. And except for the Meeting House one, I believe that everyone uses the same engine. But again, that's the type of stuff I've heard, and I haven't seen a presentation yet. Mm-hmm.
Can you expand on that?
Yes.
The agent gives you more capability to include custom text if you're running code on the endpoint.
Right. Basically, if it all depends on the application itself, because there are some vendors who will not allow you to introduce custom checks, and or the custom checks that they will allow you are only against the registry. But if I would like to do custom checks, I would like to do custom checks against applications, about services, about files, basically anything that is happening on that particular element. Some of that can be done with agentless and with agent-based, but as the list of vendors that I've seen their clients, most of them just give you the ability to do registry, and that's not enough in my opinion. Okay, so we are at the fun stuff. Basically, just a disclaimer here. I took a wide range of solutions, compiled them. Some of them I ran myself. Some of them I did analysis. Some of them I say who the vendor is. Some of them I don't. But basically, you can assess for yourself who the vendor is. And in some of them, it's really easy to understand. The list of examples is quite long. There's the DTP proxy with additional gateways, DTP proxy with authentication, DTP proxy which is protected by the switch. As you can see, there's a lot of DTP proxy. Broadcast listeners, NAC with integration with switches, 802.1x, Cisco, inline devices, and out-of-band devices. So, okay, let's start. The most easiest one to understand, comprehend, and that my mom and dad can bypass is DTP proxy. Although in my dad's case, it's really hard for him to do other tasks, so I don't know if he can change the IP address. Sorry, Dad. So basically, DTP proxy approach is by putting a DTP proxy in front of the DTP server of the organization. It will answer for the DTP broadcast requests and basically intercept them before they hit the DHCP server. It will assign usually a non-routable IP address to the element. The element would have to have an agent on it, and will, in some cases, configure the routers with access list preventing that particular IP addresses and subnet that they hand the IP from routing. Then it will probe for an agent, will do the tests. It will pass. If not, it will perform remediation. Release and renew will get it to do a recheck. And if it's fine, basically it will be assigned a real IP address on the network. So this approach is, if you look at the scalability and ease of use and how fast this can be done, this is really easy and fast. And we know that most organizations use DHCP, especially for the client system, so it looks very appealing. The problem here is that, first and foremost, not all devices are using DHCP, and it means that if you don't use DHCP, then your machine is not going to be detected by this type of solution. Also, if you assign yourself a static IP address, you're not going to be detected. So basically, we are looking at a solution that looks only at those machines that use DHCP. You must use an agent-based software in order to interact with the other pieces of the solution, the detection of the elements. Although the DHCP is a layer 2 protocol, technically speaking, in my opinion, this is a layer 3 at all, because if you're not sending DHCP, basically you're not going to be detected, no matter what other traffic you may generate. There's also a problem of how enforcement is being done. This relay on the routers. I can just, assign myself an IP address on the network that has the ability to route, and I'm home free, so the quarantine here is kind of useless. And again, this needs to be deployed across the enterprise, and if I don't know how my enterprise looks like, then there are other ways basically to get to the network. So this is fairly easy. There's also problems that we don't prove user authentication with this type of solution. If I use network address translation, I can introduce my element to the network as well, but basically DHCP proxy is a really bad idea when you would like to do a network access control. So companies took the DHCP proxy and they said, well, this is a bad idea, let's hook up other stuff to it, so we'll make it more, we'll try to make it better. Let's put it that way. So other companies, and since I'm going to show you from the manuals of one such company, then Cygate took this approach and said, well, we'll introduce inline devices, gateways per subnet, and basically they will enforce other devices that either didn't go through DHCP from escaping the local subnet. So in that cases, we have also all the problems with DHCP proxies still apply. Be on a local subnet, I can still do all my stuff. And the interesting quote from the Network Access Control Technologies and Cygate Compliance on Contact user guide is that non-Windows exceptions can be made that exempts non-Windows clients from the NAC process. Second, a MAC address-based exemption list can be built. That's really cool. So if I'm running a system that is not Windows, and there's no agent whatsoever that can be introduced there, basically all I need to do is tell my my security guys, I'm using Linux, please put my MAC address on this exception list, and I'll be fine. The problem here is, and this is really something that you'll see repeating, it's really easy to just take out of the network one such element, spoof the MAC address, and basically get the same access rights to the network. And this is something which is not only a problem of DHCP proxies, it's also a problem of most of the other NAC solutions. If we look at the slide, I have a printer. I put my ROG device. It can be whatever I want. Basically, it gets the same access rights as the printer. As a side note, the printer shouldn't send traffic through the router, but it can be an IP phone. It can be an IP camera. Bless you. It can be whatever you would like. It doesn't really matter what it is. Or since you are able to access the local subnet, you can find yourself a nice target. If you are able to compromise it, you are able to use it as access proxy to other parts of the network, and you are also fine. So this is a good example of why doing quarantine and enforcement in layer 3 is not a good idea at all. Okay, so there are other companies who took DHCP and decided, oh, okay, we'll have other fun stuff with it. So what they have done is that they completely replaced the DHCP server, and they introduced their own way to do authentication plus DHCP. So how that actually works. Basically, the user is requesting a DHCP address. Among the parameters that it gets with the DHCP reply is DNS IP, which basically is of either the same box or an authentication portal. It tries to browse the web. It is redirected to an authentication portal that asks for the username and password of that particular user, checks it against the whatever user data storage they have. If it is fine, it creates some checks, either using an agent or either using external vulnerability scanners, and according to those, do remediation or not. So this is really, sounds like nice. Of course, you know, theoretically speaking, may authenticate any operating system, et cetera, et cetera, et cetera, suffers from all the other DHCP stuff problems, but the most interesting thing is that what if I want to introduce my rogue DHCP server? So if I introduce my rogue DHCP server and I send back the same parameters saying I'm your DNS, I'm the one that you need to send your traffic through, and I redirect the user to me, basically I can not only steal the username and password of all the users that I will be able to reach them before the original DHCP server, but I will be able to get access to the network with no problem, also to get to places because I have the credentials of those users. So if you don't know, DHCP is all based on who gets there first. So if my replies gets first to those who asks DHCP address, then I'll be the winner. Okay, and the last DHCP stuff that I will be talking about is DHCP protection by the switch. So there are some switch manufacturers, actually not Cisco, but I took this slide from Cisco, that say I'm able to guard that DHCP server that you will be using will be the designated DHCP server of that organization, and I will be able to guard that the IP address that is being received by the DHCP server is the only one that will be used by the endpoint device attached to my port. Who can tell what's the problem here really fast? Here's some mumbling down there. Okay, one of the biggest problem here, this is a policy per port. It means that all your ports needs to be either statically configured or either dynamically configured, and the solution needs to know which are the ports that are mapped to be dynamically and which are the ports that needs to be dynamic statically. Good luck doing that. Especially if you're an organization that your users move all the time, that's a bad thing to have. Other stuff is that the policy is defined per port. Not only that the port needs to be static and assigned in advance, the policy is defined per port per element. It means that you can't hook up more than one element to that particular port, and if you do, then this particular thing can't be actually used. Going back to a more interesting thing here, the fact that not all of your elements would actually use DHCP, and that means you need to start doing exception list per port, and you will be susceptible to any other attack like the replacing and spoofing and other stuff. But the biggest problem here, in my opinion, is the manageability of this solution, because all of the switches inside the organization will have to have access lists that would designate the only DHCP server of the organizations to hand out the IP addresses. If you're not able to pool all of those access lists across the entire switch infrastructure, and any rogue DHCP server will able to inject the type of packets that would allow the endpoint device to have another IP address, because all of this is basically protecting the DHCP server as the one source that can handle IP addresses, and protecting the client getting the answers from that particular DHCP server. So if I'm not able to basically control all of my infrastructure and put all the ACLs across all of my infrastructure, and I will be able to put a DHCP server not even a DHCP server. Another client sends spoof DHCP replies, replacing the IP address of those clients and basically allow them to do other stuff. So that's basically a manageability nightmare rather than a security problem. Broadcast listeners is another nice thing. It's basically a client or a certain solution installed on a machine, on a certain subnet that listens for broadcast traffic, NetBIOS, ARP, and these kind of things in order to identify the element that is on the network. Basically what will happen here is that when the broadcast is heard, the solution will try to contact the agent that needs to be installed on that particular device, do all the other stuff that you already know about, and everything will be happy and merry. Well, I don't think so. The unmanaged solution is also the most problematic thing here, because here we have an element, an agent that can't be probed, and the agent software on it, or basically the agent software that some of these manufacturers use, basically prohibits the element from doing anything unless the solution tells that the element is safe to be operational on the network. So in that case, I don't have any agent, and this element can do whatever he wants on the network because there's nothing here that can basically block its access. Some of those solutions actually went and said, well, we are going to use the switches in order to provide this kind of capability and to interact with the switches in order to put this on a dedicated VLAN or isolate that otherwise. But we cannot trust the switches of the organization to basically allow us to do this kind of performance, because we can't really assess if our VLAN isolation actually works unless we have the appropriate VLAN ACLs on the access switches that prevents us from doing VLAN hopping, or that the switch that is attached to is actually capable of doing VLANs and trunking and other things. Basically, if you would like to assign another VLAN and you would like to access all of those devices, unless you if you define multiple VLANs on top of that particular device, you need to define trunking, you need to define other things. If you don't understand the entire switch infrastructure, you're not able to do that. And I'm betting that the networking people will be really, really happy to know that another solution automatically assigns VLAN ideas on their infrastructure. Really, really happy to see when they discover that. I'm sure that they will be more than happy to give their read-write access to the switches and username and password, which usually never happens. Other interesting stuff with VLAN trunks, with broadcast listeners that I'm really skimming through. Basically, the biggest issue is that there's no user authentication. We already talked about that, but the weakest thing here is with how we identify the element. So if we are looking only for broadcast traffic, then I can easily manipulate how I do stuff. So instead of, I'm not sure how many of you know that well, ARP requests are sent to the broadcast address of the network and asking whoever is associated with a certain IP address to reply. But if I know the MAC address of that particular element already, I can send a unicast ARP request to that particular element. Everything will work fine. The element will cache my stuff, the element will send me back an ARP reply, and everything will be fine and well. So basically, if I manipulate the way I'm doing ARP requests and basically don't send any other stuff to the broadcast address, these broadcast listeners will never know I'm there. I'll be happy on the network doing whatever I want. Okay, I'm skimming through to 802.1x since I have 5 minutes. No worries, I'll post this to my website. Okay, 802.1x is a nice protocol. If you don't know, 802.1x is a username password-based protocol only. So if you would like to have compliance checks, you need to install an agent software in order to provide you with that type of checks. The problem here, it's not only with the manageability side, because all of the elements needs to be configured to use 802.1x. You have legacy elements on your network or equipment that 802.1x, like AS400s printers. There are some printers that are now doing 802.1x, the new ones, but most of the printers do not know how to do that. And your networking gear needs to do 802.1x as well. So there is a high cost here to implement a solution which is based on 802.1x. First of all, you need to assess your infrastructure. Second of all, you need to see which elements are 802.1x capable and which are not, including the infrastructure. Replace the infrastructure or upgrade it. implement radio servers and other authentication means, and it means that you have a project that may run between 6 months to 2 years in order to do that, which involves millions and millions of dollars into the investment. But the biggest problem here is that after you have managed to do this, okay, you did the investment with time and money and everything, and you identified who's 802.1x compatible and who's not, then anybody can just walk to your printer, unplug it, device, spoof the MAC address, and get the same access rights to the network again. So you introduce a solution which costs millions of dollars usually, and if not thousands of dollars, hundreds of thousands of dollars, and basically it's bypassable in an easy manner of just walking to a behavioral that is on the exception list, spoofing its MAC address and getting the same access rights. Another big problem with these solutions, because they lack the type of contextual information about the network, they can't really detect network address translation devices or the presence of them. So virtualization in that means doing that and virtualization will bypass that, these solutions as well. And at the end of the day, what happens with 802.1x that is usually companies will buy a switch or two for their wireless side, or will buy a wireless access point that will do 802.1x, will put the 802.1x clients on those machines that only do wireless access, and that's it. So it will be only a part of the network, not as a network-wide implementation, because of these problems, because of these issues, that basically you do this implementation, you invest your time and effort, you manage to go over the interoperability problems with all of the components that you need to have in order to do 802.1x, and at the end of the day, someone can come just spoof a MAC address and be on the network. Last one that I'll do before they kill me for the time, and then I have time for quick questions. There are switch manufacturers that basically offer you a solution that supports network access control. Usually it means that you will need to have the same switch gear from the same manufacturer. You will still suffer from the same problems as exception list as before. Virtualization and network address translation will kill you at the end of the day. And the cost is another major thing that will happen to you there. So at the end of the day, you will have a solution that costs you a lot of money, but still users will be able to access the network without a problem. There are more slides here that talks about inline devices, out-of-band devices, NAC framework, and other things that, from time constraints, I can't really speak about. But if you have any question that you would like me to answer, I'll be more than happy to answer. Yes. What should people do is first, understand why they need network access control. If they want to make sure that only authorized elements operates on the network and then that they are compliant with the policy, then it's one thing to understand. First, understand what you want from the solution. Understand if you want to enroll that enterprise-wide, and then assess what the solution actually gives you. Whether it answers, whether it detects in real time, whether it quarantines in an isolated medium and not in a shared medium, how it's performed enforcement, how it allows guest access to the network, and so forth. You can get to have a good solution that performs these type of things, but you need to understand that not all of the solutions that have the NAC tag on them are really going to provide you with the type of solution that you would like to have. If you like to have a compliant solution, then actually a network access control solution, you need another type of solution.
What type of solution has been the most difficult to actually try to bypass?
There's no one, in particular, because yeah, they all have the problems and they all have the issues. It's just if you have a one-stop shop from one vendor, it might be harder to bypass from the security standpoint, but the people that are in charge of manageability will never let you do whatever you would like to do with security, because defining policy per port is something that is definitely no-no in most of the organizations that I know.
What do you think is most promising?
So thank you for your time. No. Okay.
It's interesting to think about how commercializing your network, meaning giving anyone the ability to do anything they want, and simultaneously removing the perimeters as a
Yeah, that's-
concept. Get rid of, forget trying to do any of these things, just go a different direction. It's interesting thought.
Oh, I'll look at it. It's sys-security.com and insidex.com. One second, I'll look everything up and I'll give you a report.